Welcome to my YouTube channel Physics Academy. Today I discuss about one important topic from class 12, electrostatics, electric charges and fields. At first I want to say what is electric charge. Electric charge, especially a property of the elementary particles of the matter, which gives rise to electric force between the various objects. That is, it is denoted by small e. When this charge is acquired by any object, then it has the capability to attract another object. The minimum amount of electric charge is 1.6 into 10 to the power minus 19 Coulomb. Coulomb is the SI unit of the electric charge. That is, when an object acquired some charges, then it can either attract or repel to another objects. It is the property of the electric charge. And now what is electric force between the two charges? To discuss it, by Coulombs law, suppose here are two charges Q1 and Q2, and the separation between them is R. Then the force acting between these two charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. Therefore, from here we can write Q1 Q2 by R square, or F equal to 1 by K Q1 Q2 by R square. In SI system, K equal to 4 pi epsilon 0. Therefore, F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. This epsilon 0 is called permittivity of the medium. Which value is 8.854 into 10 to the power minus 12. Permittivity of the medium, whose value is 8.854 into 10 to the power minus 12 Newton minus 1 meter minus 2 Coulomb square. By this Coulombs law, we can find the force between the two electric charges. Now, if multiple of charges work there at that point, then the force between the total force between the charges will be let a charge Q is present at the point O, then the force acts on that charge by this multiple of charges q1, q2, q3 dot 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 qn, total number of charges present here, we can write in this way. In first case, f1 vector equal to 1 by 4 pi epsilon naught q1 into q divided by r1 square into r1 cap. Second case, f2 vector equal to 1 by 4 pi epsilon 0 q2 into q by r2 square into r2 cap. f3 vector equal to 1 by 4 pi epsilon naught q1 into q by r3 square into r3 cap. Therefore, the total force on the charge q will be vector sum of all the forces f1 vector plus f2 vector plus f3 vector plus dot 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 plus fn vector. Then f vector equal to 1 by 4 pi epsilon naught q1 into q divided by r1 square into r1 cap plus q2 into q divided by r2 square into r2 cap plus dot dot dot. F vector equal to q by 4 pi epsilon naught into q I by ri square into ri cap summation I for 1 to n. This is the total force on the charge q due to the system of charges. This is also known as the superposition principle. So this is the Coulombs law and its some important notifications. Now we discuss about the electric dipole. What is electric dipole? When two equal and opposite charges are kept separated by a particular distance, say r, then they form an electric dipole. What is the moment of this electric dipole? Moment of this dipole P equal to any one of the charge, that is the magnitude of the charge, into the distance between the two charges, that is q into r, is the form of the moment of the dipole moment, electric dipole moment, and its unit will be SI unit, Coulomb into meter. And due to this dipole, when this dipole is present in an electric field, then we can find the electric field intensity due to this dipole at different points. Now due to the presence of dipole, the electric field at a point on the axis of dipole q1 plus q minus q, two charges, we find at this point P the electric field intensity. Let this distance is 12 between this dipole, and at the midpoint, from the midpoint the distance is say d. Now at first we have to put here a unit positive charge +1 due to calculate the intensity at the point P. Now due to this point charge plus q, the intensity, direct direction of the intensity will be in this direction u1, and due to this negative charge the direction of the intensity will be in this direction, is e2. Now from this figure we can write e1 equal to 1 by 4 pi epsilon 0 q into 1 divided by the distance from this charge to the point P is, up to this is d, and from this midpoint this is L, therefore L plus d whole square it will be. Similarly E2 we can write 1 by 4 pi epsilon 0 q into 1 divided by this distance, this is a d and this L, it will be d minus L whole square. From here we can say tell that the resultant intensity at this point P, it will be either E1 minus E2 or E2 minus E1. We have to, at first we have to find out which one will be greater. This distance is large with respect to this distance, so therefore obviously E2 will be large than that of E1. Resultant intensity at P E equal to E2 minus E1, 1 by 4 pi epsilon naught into Q, this we can take common, then it will be d minus L whole square minus 1 by d plus L whole square. We can put 2qlsp is the dipole moment. Now we can take here one consideration. If the point P is at infinity, then this distance d will be very large with respect to L, then d square is very greater than L square. Taking this consideration, E equal to 2d into P divided by 4 pi epsilon naught into 1 by d square whole square. One by 4 pi epsilon naught 2p by dq. It is the electric field intensity at a point on the axis of the dipole. Now I try to find the electric field intensity at the equatorial point due to a dipole. Take a dipole, say plus q minus q. This is the equatorial plane, is the perpendicular bisector. At this point we take P point. Here we have to calculate the electric field intensity. Now we put a point charge +1 unit positive charge here. Due to this plus q charge, the intensity direction will be along this direction, say u1, and due to this negative charge, the direction of intensity will be in this direction, e2. Okay, now by taking the different components of u1 vector, we can take two components of this u1 vector along in this direction. One component is in this direction. Let this 2 is theta, therefore this angle will be theta, and this direction, this component will be cos theta component, and it will be sin theta component. Another vector is e2 vector. Also, it can also divide it into two parts. One is along this direction, another is along this direction. If this is theta angle, this will be theta, therefore this component will be to cos theta, and this component will be to sin theta. These are the different components of the u1 vector and e2 vector. Say its point is P, A and B. From here, the magnitude of AP equal to magnitude of BP. Therefore, magnitude of u1 vector equal to magnitude of e2 vector. So hence, u1 sin theta and e2 sin theta components will nullify each other. Therefore, the resultant intensity at P will be E equal to the sum of these two components, E1 cos theta plus E2 cos theta. E equal to, we can write is 2E1 cos theta, since E1 equal to E2. Now put the values of E1 and cos theta. E1 is 1 by 4 pi epsilon naught into E1 is force intensity between these 2 points. Here is +1 charge and here is q. Therefore q into 1 divided by distance will be say AP square. What is cos theta? From this triangle we can write cos theta is this by this. This is, say, the length is 2L, and the half of the part will be L divided by AP. From here 2 into 1 by 4 pi epsilon naught 2QL divided by AP cube. 2QL is take as P, which is the dipole moment, and AP cube is nothing but we can write it in this way: AP square whole to the power 3 by 2, 1 by 4 pi epsilon naught P divided by AP square is the hypotenuse, is the perpendicular, and is the base. Therefore, if this distance, if we take r, is the distance of the equatorial point from the middle point of the dipole is r. Therefore, this one is L. AP square we can write as L square plus r square whole to the power 3 by 2. From here we can write it equal to 1 by 4 pi epsilon naught P square P divided by here we take one consideration: if P point is at infinity, then R square is very greater than L square. Then neglecting L with respect to R, we can write it R square whole to the power 3 by 2 equal to 1 by 4 pi epsilon naught P divided by r cube. It is the electric field intensity at the equatorial point due to a dipole. Thank you.